Hello. In this video, I'll tell you about scientific notation. You know, chemistry is the study of atoms and molecules. And atoms and molecules are very, very small in size. They have extremely small masses, but they have extremely large numbers. Usually in a very small quantity, a very large number of atoms or molecules are present. Let me just give you an idea of the kind of numbers we deal with in chemistry. Just 2 grams of hydrogen, which is 1 mole of hydrogen, has a specific number of molecules, and that number is 6, 0, 2, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 zeros. That's such a large number of molecules of hydrogen in just 2 grams of hydrogen. Another example, if we took just 1 hydrogen atom, what would the mass or the weight of that hydrogen be? It would be 0.002345677891011121314 15, 16, 17, 18, 19, 20, 21, 22, 23, 166 grams. That would be the mass of 1 atom of hydrogen. So we deal with extremely large or abnormal numbers in chemistry and even in science. The Planck's constant, the speed of light, they are extremely large numbers. And they create problems in calculations. Try out some simple calculation with these numbers. It's very difficult. So what do? A method of writing down the numbers, a notation, the scientific notation has been devised. And what do we do in the scientific notation? It's an exponential form of writing the number. So we write it in an exponential form to make our calculations easy. Now this number, the Avogadro's number as it is called, when you convert it into scientific notation, in scientific notation we have only 1 non-zero digit before the decimal, and the rest of the digits are put after the decimal and they are multiplied by a certain power of 10. That is the exponential form. So this number comes to be 6.022, the non-zero digits till that it's written, and this would become equal to 10 to the power 23. Because the decimal was here, we moved the decimal 23 positions to turn this into 6 point something. So we need only 1 digit before the decimal. Now let's take another example. How do we write numbers or convert numbers into scientific notation? You have a number 253.02. How do I convert this into scientific notation? This number would be equal to, what do? I shift the decimal. How many places? Just 2 places, because I need only 1 digit before the decimal. This would be 2.5302 into 10 to the power 12. Whenever you shift the decimal towards your left, that is my left or your left, you multiply the 10 by that same number. It becomes the exponent. 2 positions here, so the exponent is 2. Another example, 2233.56. This has to be converted. This would be equal to, we are shifting this, how many positions now? The decimal is being shifted 3 positions. So this would be 2.23356 into 10 to the power 3. On the other hand, if we were to shift the decimal the other side, we have a number 0.0026, and I have to convert it into scientific notation. What would I do? I would shift the decimal towards my right. So when you shift it towards the right, how many positions? 1, 2, 3. So this would be 2.6 into 10 to the power minus 3. When you shift it towards the right, the exponent is a negative value. Why? Because 2.6, when it is divided by 1000, it will become equal to this numerically. Right? So this is how we write the numbers in scientific notation. Now, how do we carry out calculations if numbers are in scientific notation? Let us take the example of multiplication and division. We have 2 numbers. 2.2 into 10 to the power 4 has to be multiplied by 4.2 into 10 to the power 2. Okay, so what do? We multiply the numerical quantities separately and the exponential parts separately. So this would become 2.2 into 4.2 into 10 to the power 4 into 10 to the power 2. 2.2 into 4.2, I'll use a calculator. 2.2 into 4.2 would be equal to 9.24. This would be 9.24 into 10 to the power. When you have exponents to the power of 10, whatever the powers are, and they are being multiplied, you add the powers. So this becomes 4 plus 2. So this is 9.24 into 10 to the power 6. Alright, so this is what we do when we multiply. We multiply the numerical part and the exponential parts are added. The exponents are added. For division, let us say we had 4.4 into 10 to the power 6 is to be divided by 2.2 into 10 to the power 4. Again, the numerical part and the exponential part has to be handled separately. This will be equal to, this is 2, so it will be 2.0 into 10 to the power 6 minus 4, which would be equal to 2.0 into 10 to the power 6 minus 4 is 2. So 2.0 into 10 to the power 2. So this is how we would multiply and divide numbers which are in scientific notation. How do we do it? Do the numerical part separately and the exponential part in multiplication. The exponents are added. In division, the exponent in the bottom is subtracted. So that is how, whatever the value is, then that is all mathematical calculations. How would we carry out the addition and subtraction? Let me remind you, in our childhood, when we carried out multiplication and addition and subtraction, let us say we have a number 1002 has to be, we have to add 52 to it. So what do? I put 5 and 2 under it in such a way that the ones fall under ones, the tens fall under tens, and so on. And only then we can carry out our calculation. In scientific notation, the exponent decides the actual position of the decimal. Therefore, addition or subtraction is possible only if the exponent is the same. So whenever you have to add or subtract in scientific notation, you must change the exponents. And the exponent, if it is the same, then the values actually have they may not remain. One of them, the one that you change, may not remain in scientific notation, but at least then you can place it numerically wherever it is according to the places of ones and tens. For example, you have 2.5 is to be added into 10 to the power 4 is to be added to 2.3 into 10 to the power 3. Now 3 and 4 are separate. Are different. We have to convert these into the same form. So let us convert this into 4. To do that, what would we do? To make this into 4, we can shift the decimal this way. So this would be 0.23 into 10 to the power 4. Now we can add these 2.5 into 10 to the power 4 plus this. The 10 to the power 4 remains the same. So take this out of the bracket. This becomes 2.5 plus 0.23 into 10 to the power 4. So what would this be? 2.5, let's do it as we used to, and 0.23. This would be 2.73 into 10 to the power 4. Right? So you do the same thing in subtraction also. You have to keep the exponent should be the same, and then you carry out your calculation and you'll get the answer. So that is scientific notation and why we do it and how we use it in scientific calculations for all our problems, mathematical problems or values that we deal with in science. Thank you for watching. If you like my videos, give them a like, a thumbs up, and subscribe to my channel and keep returning. Thank you.